students, welcome to the tutorial video for conversion of fractions to decimals, decimals to fractions. So during this time you will want to have your study guide slash foldable out, which I'm going to scoot over here to get. It's going to be this. We're going to actually add to the miscellaneous section. So wherever you put the miscellaneous section. So in this foldable, let's go to the miscellaneous section and let's split up a couple sections where we're going to go ahead and talk about conversions. From fraction to decimal is the first type of conversion, and then the second type is decimal to fraction. So what you want to do as I pace myself through this video is feel free to pause whenever needed to ensure that you catch this material, and additionally, review it as you're watching it if you need to go back and re-look at the information I'm giving you. So with that being said, let's get our foldable going, and you should also have this guided notes that we started from the rational operations. We're going to finish the example set 2 and use those examples to go ahead and model what we're going to actually do. So let's get to this foldable, and what you're going to notice is that from fraction to decimal, it really isn't anything crazy. It is what I call just division. Divide the numerator by the denominator. Okay, so really the reality is that as long as we know that we divide the numerator by the denominator, that's what divisions are, that's what fraction to decimals are all about. So if I had to put it in like a notation, if I had 8 over b, a is the numerator, and I'm going to spell that out this time. A is the numerator, and b is going to be our denominator. So this should be very familiar to you because this is standard stuff from last year. But we're just going to have to get back into remembering how to do much of these skills. So let's go to the first example over here and see if we can go ahead and apply it. I see something like -6/5. I'm going to take the 5 and divide it into 6. I'm going to ignore the negative because we're going to attach that at the end. Those are just things we keep track. Now I do notice that 5, going into 6, it looks like it's an improper, so it's going to be greater than 1. I'm going to add some additional zeros at the end and then move my decimal at the very top. 5 goes into 6 once, 5, and as I'm working my way down, I'm just keeping control of my workflow. 5 times 2 is 10. There we go. I did not need my extra zeros. Some students I know put a little arrow to bring down that next, but this is long division, nothing that you have not done before. It's just we got to apply it to negatives. My final answer is 1.2, but don't forget, I got to attach that negative. So this is all that really takes to do these types of problems. It's just conversion using long division, and we got to keep control of our scratch math because we're not using a calculator to do this. So what I would like you to try are the next 3. Okay, so the next 3 are pretty standard, but what you're going to notice, I'll just give you a couple of hints to kind of help you along with this, especially number 2. We only have to convert 3 over 8 because we know that the whole number is going to be -7 point something. That's what we're going to do. We could convert it to improper if we want, but that's going to make it a little bit more challenging, a little bit longer. But as long as we recognize that, we just got to divide 8 into 3. So I would do that here, just like this, put the extra decimals in to go ahead and denote that this could be a longer decimal, and then finish strong. So what I would like you to do is pause this video and try number 2, 3, and 4 on your own. I'm going to let the video roll for about 10 seconds, and in 10 seconds you'll hear me come back and it will go ahead and pop up the answer automatically. Go for that. Alright students, what you should see on the board is all of the answers pop up. I will say they get frustrating, so if you look at question 3 and 4, notice there's a couple of little things that I have to do. I have to make sure that I'm careful to add a lot of those extra zeros to control my workflow. Even if I don't use all the zeros, it's important to add those just from a visual standpoint. Make sure you're careful to line up those decimals properly which I am doing at the beginning, and additionally, scratch work goes a long way. You will have to use a lot of those estimation skills to give you ideas of what numbers to test. So when I was doing number 4, I said 27 into 50 is once, but once you get to 27 into 230, you got to think, what numbers are kind of close? 25 is kind of close, so I'm estimating 25 goes into 104 times. 230, that's 8. So you're using different types of estimation skills to make the scratch math easier. Additionally, number 3 and 4, I kind of threw a curveball at you because they are repeating decimals. Once you start seeing the repetition, you stop. And what I'm going to do right now is show you on the answer key, don't forget to put the little line above it to show that it repeats, and then you're done. So basically, if you're very good or understand how to do 1 and 2, you're looking all right. Those are the main ones. 3 and 4 would be more like challenge style questions to ensure you got all this information. Okay? So with that being said, pause the video as needed, but I'm going to go ahead and quickly scroll over here in a moment to look at the decimals to fractions. This is where things get a little bit trickier. So let's go to your foldable and add these. When doing decimals to fractions, we got to know about the placeholders. So if I give you something like this, 0.1234, this is called the tenth spot. The 2 is called the hundredths, and so on and so forth. So 3 is called the thousandths, and this is probably the most familiar to most students. Okay? And then 4 would be 10,000ths. We're probably not going to go to 10,000ths. Those are pretty wild looking problems and not necessary. But for sure, you should know the 3 main placeholders. Okay? 1, 2, and 3 are in the tenths, hundredths, and thousandths. Basically, when we convert decimal to fractions, we need to know the placeholders. So we're going to use the placeholders to put it over a number and then simplify accordingly. So to do so, it's really easy to see it in an example versus a bunch of written notes. Okay, so I'm going to go right to an example and kind of show you how this works. So over here in the second set of problems, let's look at something like number 5. Okay, it has negative 0.7. So I know my final answer fraction wise is going to be a negative, but what I can do is think, okay, 7 is in the 10th spot. So I'm going to put 7 over 10, attach the negative, and simplify. 7 over 10 can't be simplified any further, so it is actually finished. So that's very straightforward. That's not too bad. Okay? It's the ones afterwards, like 6, 7, and 8, where there may be some simplification and a couple extra steps. I noticed that 0.125 is in the thousandths, so I'm going to put 125 over 1,000. And at this point, okay, you're halfway done. You still have to simplify. So what I think to myself is, what number goes into 125 and 1,000, the largest? Or if you don't know the largest, start simplifying by numbers you know. So I'm going to divide by 5 because I know 5 goes into both. So quickly doing the math on the side here. Okay, I'll do that real quick here. It comes out to be 5 goes into 125 5 times. So as I'm simplifying, it's 25 over 1,000. Okay, 200 goes into 1,000 5 times. I did that in my head because I remembered it. But if you don't, okay, don't forget, you got long scratch work that you can necessarily do, and you can see the proof right there. I can still simplify this even further because I notice 5 goes into both again as I keep going down. Okay, and I'm going to basically do a little bit of this in my head. Okay, 5 over 40. And then one more step. Okay, 5 goes into 40 again. And it becomes 1 over 8. And that is my final answer. So this took me a long time, but it takes care, it takes organization, and it takes a little perseverance. Okay? So what I would like you to do is try number 7 and number 8. And I'll, once again, like previously, I'll roll the video forward for about 10 seconds and pop the answer up. One thing I will caution you about 7 and 8 is that ignore the whole number first. Okay? You'll notice that it's the decimal that we have to convert. So what I would recommend is writing the -3 down and then thinking, wait, how can I convert the 0.1? Okay, so give that a try, and I'll roll the video forward for about 10 seconds. All right, students, it should magically pop up in the screen. So if you look at number 7, I started it for you, and then basically the finish is that 1 is in the 10th spot, so it's 1 over 10. So -3 and 1 over 10. It's a mixed number. 1/10 is fully simplified. It's good to go. For number 8, we have -10. That's the whole number or integer, but it's 25 over 100 because of the 100th spot. And then we have to simplify it. I noticed that 25 and 100 has 25 as the GCF or greatest common factor. I divide it into, it becomes 1/4. If you don't remember 25 is the largest, don't forget, you can use smaller numbers like 5 goes into it, and just keep simplifying until you're done. So with that being said, check it, correct it, add to it as you need. I'm going to zoom out here to show the full set of notes. Okay? At this point, this video is complete. Please review as needed. Okay? And additionally, okay, as we're finishing this, we're going to skip a couple questions here. But your homework number 2 is the OYO. So you're going to do 1 through 16. Homework number 2 is OYO numbers 1 through 16. That will be due on Monday. We'll review it, check it in class, and ensure that everything is smooth. Don't forget, you can still pop into Zoom if you have questions over this async work. All right, thank you. Have a good rest of the day.